Hello, myself Muhammad Thajuddeen. I'm today explaining a small topic about bacteriorodopsin. Rhodopsin functions not only in eye retina, a certain region of the membrane surface of red halobacteria, Halobacterium helicolium, contains the protein bacteriorodopsin. This protein has a molecular mass of 26,000 and it is composed of one protein molecule attached in the retinal molecule via albumin bond. The absorption maximum of bacteriorodopsin is at 570 nanometer. Halobacteria are extremely halophiles which can grow in saline lakes. They have a positive phototaxis to visible light and negative phototaxis to ultraviolet light. Together with lipids, bacteriorodopsin constitutes a system that provides the transport of protons across the membrane against the pH gradient. Bacteriorodopsin functions are photo-induced protein pumps. The operation of the proton in the halophiles is coupled with the phosphorylation of ATP and with the operation of the sodium pump, which provides a desalting of internal medium of the bacterial cell wall. The Mitchell theory could possibly be applied to this system. As pointed out earlier, rhodopsin also functions as photogenerator, performing the role of proton pump. In contrast to membranes of rods and cones, the purple membrane of bacteria is crystalline rather than liquid. The molecules of bacteriorodopsin are assembled into clusters and packed into hexagonal lattice, which resides in a compact lipid matrix. In the middle of cluster, there is a channel 1 to 2 nanometer in diameter. The bacteriorodopsin molecule is 70 to 80% alpha helical. Each molecule contains 7 rod-like alpha helixes 3.5 to 4 nanometer long, which are oriented perpendicularly to the membrane plane. The size of protein is 2.5 into 3.5 into 4.5 nanometer square. Bacteriorodopsin runs through the entire membrane and comes into contact with aqueous phase on the both sides of the membrane. Bacteriorodopsin molecules are symmetrical. From the value of transition dipole moment of retinal 12 diameter it follows that on light absorption, an electron is transferred to its distance comparable with the distance between the terminal groups of retinal, the cyclohexene ring of the Schiff base. Chernavskaya and Chernavsky in 1978 examined the process on the basis of tunneling transport of electrons leading to intramolecular transformation of energy. The model consists of two potential wells separated by barrier. The wells correspond to electrophilic groups, the cyclohexane ring of retinal and the nitrogen of lysis. In the well I, there are two levels, a distance between which is equal to the energy of quantum absorbed. The levels of second well is somewhat lower than the upper level for the first well. The electron is excited by the light in the well I, tunnels from the upper level into well 2. As a result, the approach of proton well 2 becomes polarized. This is being followed by the lowering the electronic level. Being positively charged, well I is also polarized. The electronic levels are in the rise. Further lowering of the levels in the well 2 and the rise in the well 1 occur as a result of conformational changes resulting in the relaxation of new equilibrium corresponding to the new charge distribution. This followed by the reverse tunnel of the electron from the well 2 to the lower level of the well 1. By a repeated polarization, the both wells conformation relaxation to initial state. The cycles is thus terminated. The resonance conditions required for the tunneling provided by the polarization and conformational transitions. The free energy of the proton upon tunneling of an electron from 1 to well 2 is given by delta J is equal to E square by epsilon into 1 by R2 minus 1 by R1, where E is equal to 4.18 to 10 to the power minus 10 ESU in the electronic charge, epsilon is approximately 5 in the dielectric constant, and R2 is the distance from the proton to the center of the well 2 and R1 is the distance of the center of well 1. From the proton that resides near the nitrogen atoms and the Schiff base and practices in the pronotation R2 is equal to 0.25 nanometer and R1 is equal to 1.3 nanometer. So free energy delta G is approximately 1 eV. The corresponding change in the dissociation constant for this group is delta Pk is equal to delta G by 2 by 3 kT, where T is equal to 17. The change of equilibrium constant on the reverse tunneling is the same order magnitude but opposite the sign. The estimates show that alternation of properties of a group under consideration brought about by the electron tunneling can occur over entire interval of the pH values observed from the 3 to 12. The lowering of the electron level polarization expressed in the similar manner. Delta E is equal to E square by epsilon by 1 by R1 minus 1 by R2, where R1 and R2 are the distance from the proton and the center of the well before and after polarization. At R2 is equal to 0.25 nanometer and R1 is equal to 0.15 nanometer, then delta is equal to 0.75 eV. The process involves the protonization of the shift base, the explanations and the capture of the protons, the polarization of rotomization of electron, retinal and rhodopsins. The phenomenon cannot be considered to have been thoroughly studied. Despite the number of interesting spectroscopic and kinetic investigations they have been carried out. The scheme proposed by Sharanvaskeva and Sharanvaski does not contradict the available results, but directing supportive evidence is required. So that's all. Thank you.